Welcome to an introduction to the product rule of differentiation. The product rule gives us a formula to find the derivative when we have the product of two functions, seen here using function notation and seen here just using f and g. The derivative of a product of two functions is the first function, which is f, times the derivative of the second function, which is g prime, plus the second function, which is g, times the derivative of the first function, which is f prime. Now I did make a video that proves the product rule, but let's start by looking at a simple example. We know the derivative of x to the fifth, applying the power rule, would be 5x to the fourth. But if we wanted to, we could write x to the fifth as a product of two functions. We could write this as x to the second times x to the third. So if we applied the product rule in this form, we'd have the first function, which is x squared, times the derivative of the second function, which is x to the third, plus the second function, which is x to the third, times the derivative of the first function, which would be the derivative of x to the second. So let's go ahead and find these two derivatives and simplify to make sure we still get 5x to the fourth, which we know to be the derivative. So here we'd have x squared times the derivative of x cubed would be 3x squared plus x to the third times the derivative of x to the second, which would just be 2x. Well, this would be 3x to the fourth plus 2x to the fourth, which does have a sum of 5x to the fourth. Notice how when we wrote x to the fifth as a product of two functions and then found the derivative, it's the same as if we applied the power rule to x to the fifth, which is what we expect. Now we actually would never do this, but this is a nice verification that the product rule does work. Let's take a look at a more involved example. We want to find the derivative of f of x equals the quantity 4x minus 3 times the quantity 2x squared plus 3x plus 5. So this will be our first function, we'll call it f, and this will be our second function, we'll call g. And for reference, we have the product rule down here below. So we're going to set up the product rule, and then we'll find the derivatives in the second step. So f prime of x is going to be equal to the first function, which is the quantity 4x minus 3, times the derivative of the second function, which is 2x squared plus 3x plus 5. Again, we'll find the derivative in the second step, plus the second function, which is 2x squared plus 3x plus 5, times the derivative of the first function, which is 4x minus 3. So again, here we have the first function, f, times the derivative of the second function, plus the second function, times the derivative of the first function. So here's our product rule. Now we're going to find this derivative, and then this derivative, then multiply and simplify. So f prime of x is going to be equal to the quantity 4x minus 3 times this derivative, which would be 4x plus 3, plus the quantity 2x squared plus 3x plus 5, times the derivative of 4x minus 3, which would just be 4. Now we'll find the two products and combine like terms. So remember, here we'll have four products, 1, 2, 3, 4, and here we'll distribute the 4, so we'll have 1, 2, 3 products. So here we have 16x squared, and these are actually conjugates, so we're going to have plus 12x and then minus 12x, that's going to be 0, and then negative 3 times positive 3 is minus 9, plus distributing 4, we'd have 8x squared, plus 12x, and then plus 20. Now let's combine our like terms. We have 2x squared terms, and we also have two constants. So our derivative, or f prime of x, is equal to, that'd be 24x squared plus 12x And then negative 9 plus 20 is equal to 11, so we have plus 11. This is our derivative function. Now you might be wondering if we could have just multiplied all of this out and then just applied the basic power rule. In this case, we actually can, so I'm going to go ahead and show what would happen if we did multiply it out, just to show we'd get the same answer. And I already worked this out. If we multiply this out, this would be our product, combining like terms. This would be our simplified function. And now if we apply the basic power rule, notice how we would just have 24x squared plus 12x plus 11, and the derivative of negative 15 would be 0. So this is the same derivative we had on the previous slide. But in many cases, multiplying it out would be a lot more work, and that's why the product rule is so helpful. Let's take a look at one more example. Again, this is one where we could multiply it out, but there would be 9 different products to find and then simplify before we could even think of applying the power rule. So we'll go ahead and apply the product rule. So we're going to let this first function be function f, and the second function be function g. And now we'll apply the product rule. So our derivative is going to be equal to the first function f times the derivative of the second function, which is x squared plus 3x minus 9, plus the second function times the derivative of the first function. Again, notice how I'm not finding any derivatives in the first step. I'm just setting up the product rule. Now we'll go back and find the derivative here, the derivative here, multiply, and then simplify. The derivative of x squared plus 3x minus 9 is going to be 2x plus 3. And then we have the second function times the derivative of the first function. This should be 6x minus 1. Now we'll multiply this out and combine like terms. And to help us simplify this, I'm going to line up the like terms vertically. We have 3x squared times 2x, that's 6x cubed. 3x squared times 3, that's plus 9x squared. Then we have negative x times 2x, that's going to be negative 2x squared, which again I'm going to put underneath the x squared term here. Negative x times 3, that's minus 3x. And we have 5 times 2x, that's plus 10x. Again, I'll place this under the x term. Then we have 5 times 3, that's plus 15. And now we have 6 more products here. X squared times 6x, that's plus 6x cubed. X squared times negative 1, that's going to be negative 1x squared, or negative x squared. Again, notice how I'm putting it under the x squared column. Then we have 3x times 6x, that's plus 18x squared. Three x times negative 1, that's negative 3x or minus 3x. And then we have negative 9 times 6x, that's negative 54x or minus 54x. And then negative 9 times negative 1, that's plus 9. Okay, now we'll combine our like terms vertically to find our simplified derivative function. So we have 12x cubed. Then we have 9x squared minus 2x squared minus 1x squared, that's 6x squared, plus 18x squared, that's plus 24x squared. Looking at the x terms, negative 3x plus 10x minus 3x, that's going to be 4x, minus 54x, that's going to be minus 50x. And then 15 plus 9 is plus 24. So you can see we need to be very careful when multiplying this out, watching our signs, and make sure we combine the like terms. Okay, I hope you found these first 2 examples helpful. Thank you for watching.